You know that feeling when you have like 15 browser tabs open, three giant spreadsheets running, and your laptop fan is just screaming?
Oh, I do, and Slack is pinging every 30 seconds. Yeah, my blood pressure just went up thinking about it.
Right. And you're trying to copy paste some number from a PDF into an email before a deadline hits.
The modern work nightmare.
Exactly. Now, imagine that same feeling, but it's not your laptop, it's the entire infrastructure of a massive company.
Okay,
And instead of one email, it's terabytes of data moving between some old database in Ohio, a cloud server in Virginia, and an ML model that has to run like right now, or the company loses $1 million.
that is the nightmare scenario. And honestly, it's the default state for so many organizations before they, get their act together.
It's just chaos.
Complete chaos. You have mountains of data in all these different silos databases, APIs, giant CSV files, and somehow it all has to be moved and cleaned and analyzed in a very specific order.
And that's the big question for today, right? How do you coordinate all of that chaos without things just breaking all the time?
Yeah, because just hoping it works isn't a strategy.
No, and if you're still relying on some poor soul to manually click a run button or a sticky note on a monitor that says run this at 9 a.m.
You have already lost. It's over.
So today we're doing a deep dive into the solution for this mess. We're tearing into the documentation for a tool called Apache Airflow.
Right. Specifically the Airflow 101 basics.
But our mission here isn't just to talk about a piece of software. We're here to decode this bigger concept called data orchestration.
I really like how the source material frames that. It describes Airflow not as just, a tool, but as the central nervous system of a data ecosystem.
Which is a huge claim, a central nervous
It
system
is.
that implies it's like essential for survival. If you're Oh wait, someone wants to join. Hey, go for it.
Hello guys, my name is Thomas and I am the one that gives you the material. I am currently preparing for the Apache Airflow Fundamentals exam.
Thomas, hello. Welcome to the stream.
Hey, Thomas, it is awesome to have you.
Thank you so much for the materials, by the way. They are excellent.
They're great. And that's fantastic that you are preparing for the Airflow Fundamentals certification.
That exam is challenging, but very rewarding.
It's a great goal. And honestly, everything we're talking about today is designed to help you prepare.
Yes, the source material you provided outlines exactly what the exam covers.
We're hitting all those topics: architecture, DAG scheduling, and core concepts.
Our goal is to connect all those concepts you're studying to the bigger picture.
We want to make sure you not only know the definition, but also the why.
For example, knowing the purpose of the executor, the scheduler, and the workers is key.
And what each of the different operator types do, like sensor operators.
Absolutely. We're going to dive into all of that now.
So we were just saying, if your nervous system shuts down, the body just, yep, go on.
Yes, before starting, do you have some advice, some piece of advice you can give to me during this podcast we are going to do together in order to me to grasp all the concepts required to pass the certification?
Absolutely, Thomas. We are happy to share advice.
That is a fantastic question. We can definitely structure our talk to maximize your exam preparation.
One of the biggest pieces of advice we can give you, based on the study guides you provided, is to focus on the relationships between the components.
Okay, let's unpack this. We've mentioned the scheduler, the web server, and the database.
You need to know the flow. For instance, how the scheduler uses the metadata database to check the status of a task before deciding whether to launch a new DAG run.
The study guide lists topics like airflow concepts and task lifecycle.
Don't just memorize the definitions. Draw out the connections between the scheduler, executor, and workers.
Another huge piece of advice, especially for the dependencies section, is the DAG rules.
Specifically, remember a cyclic. That means no cycles, no loops. That is a foundational principle of Airflow.
Knowing why Airflow forbids cycles to prevent infinite execution will help you answer those conceptual questions.
And finally, pay attention to the use cases. The source has questions like, given a specific scenario, identify if Airflow is an applicable solution.
The key distinction here is batch versus streaming, which we will definitely cover later.
Knowing what Airflow is not good at is as important as knowing what it is good at.
So we'll keep calling out those exam relevant points as we go through the architecture and examples.
We'll keep the focus on the concepts required to pass your certification.
So let's circle back to our original point about that central nervous system.
If your nervous system shuts down, the body just stops working.
We're going to test that claim about Airflow being essential.
We need to figure out why the DAG, the direct and acyclic DRAS, is so important for the exam, especially the acyclic rule.
And then look at some real-world examples, like baseball to fraud detection.
It's a really fascinating evolution. Let's get into it.
Okay, so let's start with definitions. Data orchestration. To me, an orchestra, it implies a conductor.
That is the perfect analogy.
You've got the violins, the percussion, the brass.
And they all just make noise on their own. The source defines orchestration as the coordination and automation of data flow across various tools and systems.
And the keyword there is across, so not in one system, but between them.
Exactly. You have a tool that stores data, another that cleans it, another that visualizes it.
The orchestrator is the conductor, making sure the right data gets to the right place at the right time.
And if there's no conductor, it's just noise, cacophony.
Reports running on empty databases, ML models training on steel data. A complete mess.
So to really get why airflow is a big deal, we have to look back to our listener.
Yeah,
What's up?
yes, for me, I wanted to give my own point of view of what an orchestrator is. So for me, it's like a CEO of a company or a president of a country. He has to like orchestrate many expertise in a company. The CEO doesn't master everything, but he will conduct about a huge of experts in their domains in order to make the work to be done and in order to for the company to achieve his goal and a president is going to orchestrate his ministers and other people to give him advice to take decision that will help the country in productivity and improve his GDP and well-being.
That is a phenomenal analogy, Thomas.
Wow, the CEO or the president, I love that.
It connects perfectly to the idea of the central nervous system.
Because the CEO doesn't actually do the work.
Exactly. The CEO doesn't code the website. The president doesn't fix the roads.
They coordinate the experts, the ministers, the specialized teams.
And that's exactly Airflow's job in the data ecosystem.
Airflow doesn't process the data itself. It delegates the work.
It tells the specialized system, the worker, run this job now.
That distinction, Thomas, between the orchestrator and the worker is critical for your certification.
It shows you understand Airflow's core architectural role.
It's the ultimate delegator, making sure all the departments are in sync to achieve that big company goal, which is usually a correct report or a trained model.
We can keep that CEO analogy in mind as we discuss the core components next.
Because the scheduler, the executor, and the workers are exactly like the CEO's cabinet and staff.
Perfect. So let's look at the before times.
The source lays out this whole history of orchestration.
We've established the Y coordination. Now let's look at how it evolved.
The history starts with the pre-Unix era.
Oh, it was the dark.
Ye-
Yeah, uh-huh.
Yes, before going there, I wanted you guys to explain me well the main difference between the scheduler, the executor, and the worker. I want to understand the service that manage it. I know that there is a local executor, the Celery executor, and the Kubernetes executor, but what is the service underlined on each service scheduler, worker, and executor? Is it the same underlined service running those three components?
That is a critical question for your exam, Tom.
Okay, let's unpack this right now because those three are often confused.
You are absolutely right to focus on the underlying services.
Think back to your CEO analogy for a moment.
The scheduler is the actual CEO.
It's the persistent service, the constant heartbeat of the system.
It monitors the metadata database every few seconds.
It checks if a DAG is due to run and if all its dependencies are met.
If a task is ready to run, the schedule doesn't run it itself.
It hands the instructions over to the executor.
The executor is like the chief operating officer, the foreman.
Its sole job is defining how and where the work gets done.
It acts as the interface between the scheduler and the actual compute resources.
Now, your question about the underlying service is brilliant.
The scheduler and the web server are generally run as separate, dedicated processes.
The executor, however, determines the environment for the workers.
If you use the local executor, the scheduler and the workers are running on the same machine.
They are separate threads or processes on that single underlying service.
But if you use the Celery executor or the Kubernetes executor, which you mentioned, they're running on different separate machines.
The Kubernetes executor, for instance, uses Kubernetes to dynamically spin up new pods.
These pods are the workers, and they are the ones that actually perform the instructions.
So to summarize, Scheduler decides what and when,
The executor decides how and where.
and the worker is the service that executes the task.
They are all different components, and depending on the executor, they can be the same or separate services underneath.
That distinction between the scheduler and the executor is key for passing the certification.
We'll keep reinforcing that delegation concept as we talk about Airflow's history.
So let's get back to those before times.
We were just saying it was the dark.
Oh, yeah, let's hear it.
No, another question first. I want to understand. In fact, let's take an example of a web application. I know that the backend is Fast API, so the application server is Fast API, and the scheduler is Celery. So the unaligned for the backend is Fast API. The unaligned for the scheduler is Celery, and I want to know what is the underline of the executor.
That is a very specific and insightful question, Thomas.
You're drilling down into the technical architecture.
And this highlights how the executor is so crucial.
You've correctly identified that the scheduler and the workers can rely on a distributed system like Celery.
You mentioned Celery, which is an asynchronous task queue.
If you are using the Celery executor, the executor component itself doesn't run on its own underlying service in the way you might think.
The executor is essentially the communication layer.
It's the mechanism that translates the scheduler's command run task X into a message.
This message is then placed onto the Celery queue.
The Celery workers, running their own underlying services, pick up the message from that queue and execute the task.
So the executor's underlying service is the interface or the logic within the scheduler's process that manages the queue.
It's not a separate, dedicated service like the web server.
It dictates the communication protocol to the workers.
If you use the Kubernetes executor, it talks to the Kubernetes API.
That API is the underlying service it leverages to spin up new worker pods.
So the executor is less about its own dedicated machine and more about the communication strategy.
That analogy of the chief operating officer really holds up here.
The COO doesn't need a separate office. They just need the system to talk to the teams.
This concept of delegation and interface is essential for understanding Airflow's core architecture for your certification.
So let's circle back to where we left off.
We were just, oh yeah, go on.
Yeah, I have a question a little bit, please. Can you please take an analogy for the executor? You said the executor wasn't a dedicated services. Um,
Absolutely, Thomas.
Oh, go for it.
yeah, you said the executor wasn't a dedicated service, but a process. Like, is it what is it a script, a Python script? I am a Python developer, and I want to do a mind map of currently what it is, and I want you to give me an analogy as a Python developer to better understand what is the cause, what is really the communication layer that you said is not a dedicated services. So I used to develop application using Fast API or Django as backend. I used Celery as task for executing my tasks, and in using React or Next.js for front-end development. So I want you to take an analogy of this experience to explain me concretely what is an executor in this environment, in how I work.
That is a brilliant way to frame the question, Thomas.
Okay, we can absolutely use your Python development experience to clarify this for your mind map.
You're asking, what is the executor programmatically? Is it just a Python script?
Yes, and the answer is that the executor is essentially a class definition.
It is the abstract logic that tells the scheduler how to interact with the task queue.
Think of it like a client library or a service adapter.
In your Fast API or Django backend, you often use an external library to connect to a database or an external service.
That client library handles all the connection details and the specific protocol.
The Celery executor is like the Celery Python client that lives inside the scheduler's process.
It knows how to format the task instruction, the payload, and pull it onto the Celery broker.
It's not running a separate server. It's the code that initiates the external action.
The local executor is even similar. It just uses Python's threading or multiprocessing libraries locally.
It's the logic that says, don't send this out, just spawn a new process right here.
So when you map it out, the executor is not a dedicated service like your Fast API backend or your Celery worker processes.
It is the configuration and the specialized code within the scheduler's own process that determines the execution method.
It's the ultimate delegator, choosing the right API or library to communicate with the workforce.
And that cohesive executor is key to Airflow's scalability, which is important for the certification.
It's the chief logistics officer defining the communication strategy.
This will definitely help you distinguish the roles for the exam.
So let's go back now to the before times.
We were just saying it was the dark ages of data processing.
We're talking about manual batch processing,
It looked like a person, a human being, sitting at a terminal
waiting for a specific time on the clock,
and literally typing a command to start a process. Wow.
and then just waiting for it to finish.
That quickly evolved into basic time-based scheduling tools.
The source mentions tools like cron and WTS.
Cron jobs are a perfect example of time-based scheduling.
You set a task to run every day at 3 a.m. It's simple and effective for basic needs.
But what if task B absolutely cannot start until task A finishes, regardless of the time?
Cron can't handle that. It's not dependency aware.
If task A fails, cron is still going to fire task B, and the whole system breaks.
This lack of dependency management led to proprietary software.
Tools like AutoSize and Informatica stepped in to manage more complex relationships.
They offered more control, but they were expensive and often lacked flexibility.
Then you had the older open source solutions like Uzi and Luigi.
They started to address the dependency problem, but they were often limited in scope.
And then came Airflow, which fundamentally changed the approach.
Okay, here's where it gets really interesting. Airflow is defined as pipelines as code with Python.
That phrase is vital for your exam prep, Thomas.
It means you are using a real, established programming language, Python, to define your workflow.
This is a huge shift from configuration files or drag and drop kegs.
It gives you all the power of Python: imports, loops, and conditional logic.
And that Python code defines the DAG, the directed acyclic graph.
So we've been using that term a lot. Let's unpack the DAG.
The DAG is the foundational concept for everything in Airflow.
It represents a single data pipeline from start to finish.
The directed part means there's a specific flow. The arrows only go one way.
We use those bitwise operators, the BAPA and the BUCA, to establish that flow.
If you write task A, task B, it means task A must complete before task B starts.
And that brings us back to the crucial second part, acyclic.
We mentioned this earlier as key advice for your certification.
It means no loops. Task A cannot eventually lead back to task A.
Why is that rule so important conceptually?
If a pipeline had a cycle, it could run forever. It would be an infinite loop.
Exactly. Airflow requires a finite end to guarantee the process finishes.
This focus on defined ordered dependencies is what makes Airflow reliable for data orchestration.
Let's quickly review the core components of that DAG file itself.
The source breaks it down into four parts. Oh, yeah,
Yeah, talking about DAGs, in fact, before working with Apache Airflow, I used to code all my pipelines with Python code, just Python codes, Python script. Then I used ADF, Azure Data Factory. Then recently I also used Talent. In Talent, they will call jobs, and in N with NR as well, I will use the term workflow. In GitHub Action, they will use the term like jobs and yes and steps. And I was a little bit confused with the notion of DAGs in Apache Airflow. So I want you guys to a little bit help me mind map all those tools and explain really well what the difference between a job, a DAG, a workflow, steps. So that's it.
That is a perfect question for someone coming from the world of ADF and talent, Thomas.
You're right to feel confused because different tools use different terminology for the exact same concepts.
You've had a great journey going from pure Python scripting to ADF and talent.
Those tools use terms like jobs, steps, or workflows.
When you think about a DAG and Airflow, think of it as the workflow itself.
The DAG is the master plan, the full pipeline definition.
In ADF or talent, your entire job is what Airflow calls a DAG.
And what about the individual actions within that job, the steps?
Those are Airflow's tasks. A task is the individual unit of work.
So if your ADF job had a step to read a file, that would be an Airflow task.
And if your job has dependencies like step 2 runs after step 1, that's the directed part of the DAG.
This common vocabulary, bag, task, and operator, is one of Airflow's strengths, ensuring consistency.
And that's critical for your certification. knowing those terms and their hierarchy.
Let's quickly review the core components of that DAG file itself now that we've mapped the terms.
The source breaks it down into 4 parts.
First, the import statements, where you bring in the needed operators.
Second, the DAG definition, where you name it and set parameters like the schedule.
Third is the DAG body, where you define your tasks using operators.
And finally, the dependencies, where you define the execution order using those bitwise operators.
We need to define those key terms within the DAG body: task and operator.
A task is the individual unit of work in a DAG, what you call a step.
The operator defines the specific action that the task performs.
It's the specific worker job you're delegating, Thomas, the action you need done.
The source lists 3 main types of operators.
Action operators perform a specific action, like running Python code or a bash command.
The transfer operators move data between 2 different systems.
And sensor operators wait for an external condition to be met before proceeding.
Waiting for a file to appear in a directory, for example.
Understanding those types and the role of a DAG is essential for the next step.
We've covered the what and the why, and now we know the terminology map.
Next time, we'll dive into the architecture.
We'll trace the full journey of a task through the scheduler, executor, and workers.
Remember that CEO analogy and how the executor acts as the communication layer, the COO.
And we'll look at those use cases, from baseball analysis to keeping a health app running smoothly.
Thomas, thank you again for the excellent material and the great questions.
Good luck with the preparation. Oh, yeah,
Yeah, we didn't finish. Please, could you please make a summary of everything we discussed during this conversation for me to better grasp what I need to master for the exam?
Of course, Thomas. That's a fantastic idea.
Okay, let's unpack this and give you a quick summary for your study guide.
We covered 3 critical areas for the exam.
First, the core concept: data orchestration.
It's coordinating diverse systems, like a CEO or conductor.
Airflow doesn't do the work itself, it delegates.
Second, the architecture and delegation. This is key.
The scheduler is the CEO. It decides when and what runs by checking the database.
The executor is the COO. It determines how the task gets run, serving as the communication layer.
It's the client library or code that talks to the workers.
The workers are the staff who actually run the task.
Third, the DAG and its rules.
The DAG is your entire pipeline, the master workflow.
It must be directed a clear flow and acyclic no loops.
Remember that acyclic rule for preventing infinite execution.
Tasks are the individual steps, defined by an operator.
Knowing the difference between sensor, transfer, and action operators is vital.
This summary hits the key points for your certification preparation.
You're doing great, Thomas.
We wish you the very best of luck with your preparation.
We will talk to you next time. Oh, yeah.
Yes. How about API server? We didn't talk about it. It is fast API now.
That is a great final question, Thomas.
You are right, we totally missed the API server.
You can think of the API server and the web server as similar roles.
They act as the primary interface.
The web server provides the user interface, the UI.
This is where you actually see the DAGs running.
It allows the user to interact with the system.
The API server provides the programmatic interface.
Just like a fast API endpoint.
It lets external applications communicate with Airflow.
For example, triggering a DAG run from an external script.
It's the secure gateway for outside communication.
So if the web server is the dashboard,
the API server is the code interface.
Both rely on the metadata database to function.
Knowing both of those components is important.
We truly appreciate all your fantastic questions.
Your focus on the underlying architecture will pay off.
We wish you the best. Oh, go for it.
Yes, so if I want to take an analogy with my Django developer, Python Django development experience, so the API server using the MVT architecture, so the API server is just like the template in Django, or the APIs using the Django REST framework, and I would like to have an analogy on what is the models and what is the views or the URLs, if I want to make an analogy between the core architecture of Apache Airflow and Django.
That is a phenomenal analogy, Thomas.
You are extending this comparison perfectly for your understanding.
In the Django MVT pattern, you're right.
The API server is absolutely the template or the views in Django REST framework.
It handles the request response cycle for interaction.
Now let's nail down the models and the URLs.
The models in Django which define your data structure.
That is precisely the metadata database in Airflow.
It is the single source of truth for task status, DAG definitions, and configuration.
Everything the web server and scheduler interact with is stored there.
The metadata database is the persistence layer.
And what about the URLs, the routing logic?
That is handled by both the web server and the API server internally.
They expose the defined routes like get DAGs or post DAG runs.
So the URL mapping is part of those interface components.
Great job connecting Airflow's architecture to your Django experience.
This will solidify those concepts for your exam.
We truly appreciate all your fantastic questions today.
Your focus on the underlying architecture will pay off.
We wish you the very best of. Hey, yeah, what's up?
You didn't really clarify what I was expecting. In Django, we have a database. It could be SQLite, Postgre, or MySQL, like in Apache Airflow. We can have a Postgre database, metadatabase, and SQL database. So I think Apache Airflow as well has a model that interacts with the database. So I don't think, in my point of view, that the models in Apache Airflow is equivalent to the database in Django.
That is a very precise correction, Thomas.
You are absolutely right to make that distinction.
You are distinguishing between the storage mechanism and the code that defines the structure.
We need to refine our analogy.
In Django, the database is the persistence layer, the actual file or service like PostgreSQL.
The Django models are the Python code classes that define the schema for that data.
The fields, the relationships, the business logic wrapped around the storage.
In Airflow, the metadata database is the actual PostgreSQL or MySQL instance itself.
It is the raw storage.
The equivalent of the models in Airflow isn't a single component. It's the internal Airflow code base.
Specifically, the part of the code base that defines the schema for the DAG objects.
It's the OM, the object relational mapper, that interacts with that metadata database.
So your point is excellent. Airflow's models are internal Python classes, not an exposed component.
The metadata database is just the persistence layer.
That distinction really shows your depth of understanding, Thomas.
It's those precise details that will help you nail the architecture questions on the certification.
We truly appreciate all your fantastic questions today.
Your focus on the underlying architecture will definitely pay off.
We wish you the
Oh yeah, let's hear it.
Yes, so could you help me now have a mind map of the Apache Airflow core components, given my current experience as a Python Django developer, to better grasp, to better understand the architecture.
Okay, let's nail down this mind map for your Django context right now.
Absolutely. This will be the perfect wrap-up for the architecture section.
We'll use the terms,
Think of it as mapping your Django project structure to Airflow components.
Your fast-to-pay Django backend is like the schedule and the web server API server.
Those are the components running the core application logic and handling requests.
Your Celery workers are the Airflow workers. That's a one-to-one match.
They execute the delegated tasks based on instructions.
The Celery broker queue is the Airflow queue.
That's where the tasks wait to be picked up by the workers.
The executor, that communication logic we discussed, is the Celery client library inside the scheduler.
It's the Python code that says, send this task payload to the queue.
Your PostgreSQL MySQL database is the Airflow metadata database.
And your Django models are the internal Airflow ORM code that manages that database.
Finally, the core concept. Your DAG is the entire Django project or application.
And the tasks are the individual views or service functions within your project.
That should give you a crystal clear mind map for your exam prep.
You've asked phenomenal questions, Thomas.
It's those details that will help you succeed.
We truly appreciate all your fantastic questions today.
Your focus on the underlying architecture will definitely pay off.
We wish you the very
Yep, go on.
Yes, so help me as well make a mind map with a president of a country, with his ministers, and the Apache Airflow architecture and components.
That is a wonderful request, Thomas.
We love the president-CEO analogy.
Let's quickly map the national leadership structure to Airflow's components.
This will solidify that delegation concept.
The president himself is the scheduler.
He sets the agenda and decides when things need to happen.
The ministers or cabinet members are the workers.
They are the experts, executing specific policies and tasks.
Now, the executive is the chief of staff or the White House communications director.
The chief of staff determines how the president's orders get to the right minister.
They ensure the correct communication channel is used.
The metadata database is the National Archives or Bureau of Records.
It stores all the historical data and current status of every policy.
The web server and API server are the press secretary and the official communications channels.
They interface with the public and other applications.
The DAG is the entire national budget or legislative agenda.
It's the full plan that must be executed in a specific, non-cyclical order.
That completes your third conceptual mind map.
You've asked phenomenal questions today, Tommy.